My name is Venkat Ayadevara. I'm the program manager lead for Exchange Web Services, and this is Dheeraj on my team. He's a program manager for the same space, and I'm really excited to be here. We are doing a brief overview of Exchange Web Services. I know Matt's doing a more detailed dive into throttling tomorrow, and then we have some, I think, time block for one-on-ones. So as we go through the deck, I have a tendency to start speaking too fast. If I do that, please let me know. I want to make sure you can understand the talk. And Dheeraj and I will both be covering the talk. I'm going to go through an intro and overview section. Dheeraj will go through some of the details on Exchange Web Services, and I will cover Auto Discover at the end. So with that, can we get started? Sure. So as I said, we're going to cover what Exchange Web Services are, just some brief overview, and then Dheeraj will talk about schema versions. A big selling point of EWS is that we offer backwards compatibility to applications by having the applications say which schema version it wants the server to follow. And we'll talk about how EWS Managed API makes it much more intuitive and pretty easy to consume Exchange Web Services. And then some nuts and bolts, best practices, authentication, Auto Discover. Although throttling is mentioned in the outline, because Matt's doing a more detailed dive tomorrow, we're not going to cover throttling today. Rather, I'd like to leave the room, that time open for Q&A so that we can get some of the general question and answers out of the way. So moving on to introduction, what Exchange Web Services is, it's a standard SOAP web service. So till the history of Exchange programmability is we've had a pretty long history and a little too rich a history. Many APIs came in, we phased them out. But starting 2007, we have standardized around the web services, the Exchange Web Services. And as all of you invest a lot of engineering resources into building applications which integrate with Exchange, we want to make sure that we can, that we have standardized around this around this programmability API to make sure that you don't have to constantly redo your applications. And it's standards-based, so as long as whatever platform you use, as long as you can use HTTP SSL, so this is always over HTTPS, as long as you can marshal and marshal XML, and you have support for SOAP, then you can consume our web service. And this combined with Auto Discovery, which is the ability to supply an email address and credentials, and be able to automatically find out where the Exchange Web Services endpoint is for that user, makes it very powerful. Because what you can do then is you can, whether the user is on premise on an Exchange installation, or they're in Office 365, or a customer of yours has some users in Office 365 and some users on premise, the application can use this Auto Discovery to figure out where the endpoint is for that user, and then it can use the standards-based API to go retrieve any information from the store, from the mailbox. And the type of information stored in a user's mailbox is email, calendaring, contacts, and tasks. And not only is, I think, an important thing to remember with this as compared to MAPI, which a lot of applications were built using, is that with Exchange Web Services, you not only get the data, but you get the business logic. So the API itself is action-oriented. You create an item. So when you create a calendar item, what you're really doing is you're leveraging all the business logic which Outlook, for example, provides. So whether it's kicking off the invite email, marking who's responded, who is not, all of that's taken care of by the server, which means that, especially with something like recurring appointments, it's a lot less complicated for the application. Imagine if you were trying to manage recurrence appointments using MAPI, then you have to keep track of all these properties, are they in a consistent state or not. With web services, it's much, much simpler. And we also have the EWS Exchange Web Services also provides a way for the client to receive notifications. There are several types of notifications and synchronization. So that if you were trying to build a email client which stored an offline copy of the email, well, we have support for that as well. And It's a stateless, it's really mostly a stateless API, and it's very friendly in terms of load balancer firewall configuration because it's using HTTPS. So as long as the firewall lets through HTTPS, you should be fine. We don't require affinity to a specific client access server. So what I mean by that is your requests could land on any client access server for most operations. We recommend you maintain affinity by providing this cookie, and that leads to optimal performance. And in the case of some types of notifications, actually, for all notifications, you have to land on the same client access server because a specific server stores the state of the notifications. So that's a quick overview. Any questions? So as I said before, the web services platform it's platform agnostic. So if you're on .NET, then we highly recommend you use our managed API because it leads to a much more intuitive programming model, a lot less lines of code, and most of the functionality of the SOAP API is in the managed API. If you using Java, then we have a Java API version as well, where we make the source code available publicly because that's not as updated as often, but we allow our partners to actually modify it to suit their needs. And as long as whatever client you're building, whether it's PHP, Java, .NET, as long as it can post XML and process HTTPS, then you're good to go. And generally, in most of these platforms, there are if we don't have a managed API which meets your needs on your platform, then you could always use one of the auto-generated proxies available to generate the classes for the SOAP API. So what are the different application models? We've seen three broad classes. There is the people building client applications. Within Microsoft Outlook, some of the Outlook functionality uses Exchange Web Services, and Outlook for Mac is entirely based on Exchange Web Services. Lync also uses Exchange Web Services to look up FreeBSD information. And in the case of these types of clients, what's really convenient is if you have a lot of storage available on the device where the client is running, so you may want to go for a sync model where you use the sync and notifications to always keep a copy of the user's mailbox on the device, and you could use the EWS operations to actually post back writes. So any modification the user makes, you can use the operations to post back. And portal applications are where universities tend to build these, where they're building these, a place where you can book resources. Could be projectors, could be classrooms, things of that nature, and you want to publish availability of that. And finally, what is also quite popular is, especially in CRM, for example, background jobs. So if you have a CRM system where you have a lot of information about the customer, what's the last time they signed a contract, information, when was the last meeting with them, and so on, and you have the same person as a contact in your own mailbox, then what you can do is you can have this background job running, and usually this background job is running something called application impersonation. So it impersonates the user. I'll go into more detail into what that means in a subsequent slide. And even while the user is not logged in, it's updating the user's contacts in their mailbox with these details from the CRM system, so that if they were to look up the contact from their email, from within Outlook, for example, those additional details will be available as markup. So that's a third type of application where you're using a background job to actually synchronize, write, or retrieve some data from Exchange. So with that, I'm going to turn it over to Dheeraj, who's going to talk a little bit more about the nuts and bolts of EWS.
Thank you, Venkat. So Venkat touched base a little bit on the schemas, and just to understand that whenever we define new features or add new features to the EWS, basically we have to create new schema. So whenever new features are added, the new schema definition is created. As you see that these are the different schema versions we today support, like starting from 2007 to 2010 SP1, SP2. And just to keep your code base simple and to work across all different Exchange server versions, basically what you can do is you can start with the lowest schema version. So lowest schema is basically if you pick like let's say 2007 SP1, it has most of the core functionality what you would like to play with. So for example, synchronization, notifications, delegate management, right? So all the core features basically you can work with 2007 SP1. And then you can maintain and keep your code base simple. And if you want to take advantage of any new features, then basically fork your code to just do that and access the new features. So that's the way basically you can simplify your coding. So so we touched base a little bit on this one. So always request a specific schema version when you are working with the AWS. Use 2000 SP1 to take advantage of all the core features. And then maintain your code base and keep it simple as when you are using with 2007 SP1 schema. Any questions on the schema side? Okay, with that I will move on to the managed API portion. So we talked about the server side, how server AWS services are maintained and how the schemas are created. So let's talk a little bit on the client side, how you can code with Exchange Web Services and how you can take advantage of AWS features. So just to begin with, like it's a SOAP-based, XML-based standard service, right? So to begin with, you can think about like just start with the plain XML or SOAP handling. So you can write your own app, basically, and you can work with this XML SOAP requests and responses. But this is kind of cumbersome, right? I mean, it supports it's a cross-platform, so that's the advantage. But you have to do a lot of manual plumbing in that. So and it doesn't have any client smart logic, which I will get in a minute, how it can be supported in managed API. So this is one way to deal with or access AWS services. The other option could be a public WSDL, right? So you can create proxy classes. You can generate your proxy classes so that you can have some object-based access to the AWS features. So that can basically give you more upper hand compared to the handling raw XML. It again supports multiple platforms, not all platforms, but most of the platforms. Again, there is no smart client logic, which we have introduced as part of managed API. So as you have seen that how much line of codes you are writing, right? So all those number of lines of code, basically when you use managed API, you just simply write one line of code to access the folder, right? So this is basically a lot of work is done for you, and you can take advantage of that. It's totally object-oriented model, so it basically works well with your existing business apps and client-side apps. And the managed API is supported on Windows platform, right? So it's a .NET redistributable package. What we do. Ultimately, you see that as you move from raw XML to managed API, it basically increases your productivity. You don't have to worry about basic things, how the requests and responses are sent, what properties and attributes to worry about. So it basically simplifies overall coding functionality. It's a redistributable .NET assembly. You can download it from MSDN site. One good thing about it is it's shipped royalty free. So you don't have to worry about the royalty and the licensing issues here. And mostly it provides a large subset of whatever the AWS service features we add on the server side, right? So you are automatically covered for any new features, so they will be automatically exposed in managed API. So you don't have to keep track of things. There is a documentation associated with managed API, and it's a lot of blogs. Basically, we have written to support this managed API.
Yeah, and if there are APIs which you see in the SOAP which are not present in the .NET Managed API and would like to utilize them, we would like to know, because obviously one of the factors we take into account is what partners are looking to use, prioritize our roadmap.
Right. And as Venkat mentioned before that this is available in Java flavor as well. So we have a Java version of managed API. It's an open source community, and it's very active community, so you can take advantage of Java flavor of AWS managed API as well. Any questions on this? How many people are using managed API today? Okay. And how many people are using like proxy generated classes versus like raw XML? Okay. How is it, so you are using like both flavors. How is your experience with the managed API?
It's definitely easier to use.
Right.
But there are definitely some issues.
Okay, sure.
That's why I had to
Okay, sure. Okay, thank you. So there are certain best practices what we recommend when you are using managed API. It's not thread safe. So any objects, like for example, exchange service object which you will use to establish the connection with the server, you need to make sure that you call it per thread. Don't share it across different threads. And other thing to keep in mind that it doesn't maintain the connection to the server, right? So it's not like a connection-oriented kind of, it's a stateless protocol. So those couple of things to keep in mind. Tracing is your friend. Basically, once you enable tracing, it will help you as well as it will help Microsoft support. So let's say if you run into some issues, what are the issues, like how you can basically track those issues, right? It could be just as simple as my request is not working, or I'm running into some performance or latency issues. So you can basically make use of traces, because it emits XML requests and responses. So you can basically have them hand over to Microsoft support, which can tell us like which schema version it's using, what attributes and properties have been passed back and forth between Exchange server and client. So we can able to diagnose the problem for you. AWS, and the last recommendation what we have here is like use it as a synchronous API because it works pretty well for your, and it's very optimized for that model. And it's just as what other .NET APIs you can use. So it's on the same line. Okay. With that, I will go a little bit into the troubleshooting diagnostic kind of information. So when you run into some issue, we need to know who is the client and how we can identify the client, because it's a tons of clients, applications using Exchange Web Services. We need to pinpoint a particular client. So we recommend to use the custom agent string as part of your application, so that once you specify this agent string, we can able to track you down in the logs. So let's say if you run into some issues and you say, okay, this is a problem, then we can go back to the log and can correlate all those log entries against your user agent, whatever the string you have basically provided. So that way we can correlate and pinpoint the client app. It's another use of user agent string is, let's say if you want to limit the access to your AWS services, right? As an administrator, how you can do it? Basically, you can make use of user string, and you can allow or block certain users or certain clients to access your web services. That's another use of user agent string. Now, IIS logs. So we use IIS logs a lot for diagnostic purpose. Again, it's a web service, so we need to know like if there are any performance issues, latencies issues, and things like that. So what we do that we log the frequency and type of operations which are made by a particular client, and we also track some latencies. For example, the cache server, client access server, talks to the mailbox server through RPC protocol. So we track how many requests are made or how many operations are made for particular EWS request. Um, um, and then we also track how many requests we made to AD, right? And then latencies for those operations. So that way we can basically figure out that what's going on in the backend side, and we can able to give you some good explanation about why you are running into some particular issue. Any questions so far? Yes.
Yeah, I have a question.
Yeah.
The API is stateless. Is there some connection caching going on beneath the covers by the managed API?
I believe so. I think whatever. Yeah, go ahead, Matt.
Matt.
You're gonna
So, do I need a mic or anything?
Yeah. Yeah.
Yes, so the question was, given that EWS itself is stateless, is there any caching going on in the managed API? And there's not. So there's the Exchange service object is an object that you create. So you give it credentials, you can do auto discover, get your URL, and that it maintains that state of those initial settings that you set up. And then that's the object that we were talking about before that's not thread safe. So you would essentially provision one of those objects on every thread, and then make your calls. On the client access server, though, there is some state managed where you would get an efficiency of opening mailbox connections if you sent your request to the same CAS server every time.
So the reason for that is every time you make an EWS request, the first time it gets the request, it's fairly expensive to take all the kind of user information from the mailbox and load it. And so once it's loaded into memory, it's very efficient for your application to constantly go back to the same client access server because then you skip that expensive upfront step. Also, the second thing is this is especially useful against the data center when you make calls. We basically support basic auth over SSL. And when you do that, if you set pre-auth equals true and then you keep going back to the same server, that's also good. It minimizes the number of round trips and you get the caching of the state in memory. So that's useful.
But do you get a new connection open on every managed call?
I think I know the .NET does some optimization underneath the covers, so there may be some connection caching going on underneath the covers by .NET. The managed API itself is not doing that, but the .NET could be doing it. And there are different, I think we don't have the list of flags here, but you can use those flags, I believe, to customize whether it's reusing or not. Sorry, go ahead, Matt. You're going to say something?
No, I think that's basically it's all built on top of the framework. So it's EWS managed API just calls into HTTP web request in the framework, and so the TCP optimization there in the framework for TCP connection
exactly
is all handled by the framework. There's nothing special that you have to worry about at this level. Yep.
Yeah.
Okay.
Go ahead.
Sure. You have anything to add, Venkat?
No, go ahead.
Okay. Thanks, Matt. So just to show you how the log entry looks like, so highlighted in red is basically how we can basically figure out that this is a SOAP action, get atom, and these are the RPC and LDAP kind of counts and latencies. Basically, that's how we can correlate your events with the client app.
Yeah.
So there is one more diagnostic information what we can use in this case is a request ID header, which we basically it's a unique GUID basically which is sent back in every EWS response, and that you can use again as a diagnostic. When you say that you are running into some particular issue, then you can basically use that request ID and send it to support, and then support can track your series of requests and responses associated with that request ID. This feature is mostly Exchange Online, Office 365 at this point.
And the reason we have to do that is when you're working with an on-premise customer, you could get access to the Exchange Server logs. With Office 365, that is not available. So therefore, the request ID becomes very important, because the request ID, and there's, I think, one other header, which tells you which client access server returned you the response. But at least, at the very minimum, giving us the request ID means we can quickly track down and go extract the relevant log entries and see what is going on. So.
Yeah, request ID and diagnostic.
Xdag
info. Couple of. So we have blogs and MSDN articles. You can go and look for those that information. Right? So with that, I will talk about like Auth-in and Auth-Z, kind of a part of the presentation. So how the authentication and authorization happens with the EWS. So IISS is still used to authenticate the user request. And then Exchange basically has authorization models. So we have like 3 different models what we support in EWS. One is like a direct logon. The second one is the delegate access, and the third one is a impersonation. So direct logon is, you can think about like Entourage or Apple, mail client, where you are accessing your own mailbox. So you are authenticating as you and accessing your own mailbox. Delegate access is something where some particular user gives specific permissions for specific folders, and then that user can access your mailbox or your folder on behalf of you. So that's a delegate access. While the impersonation is kind of a very special, and it's very useful for web server applications or line of business applications, where you are kind of pretending to be someone else, right? So for example, you have an admin account which you want to go and access, thousands of user accounts, right? So you can use application impersonation for that purpose. So delegate and impersonation, it has little bit difference. For delegates, you have to have a one-on-one relationship, right? You have to enable that one-on-one relationship between users and give the access. While impersonation is like, I will dive little bit deeper into that on the next slide. But impersonation is basically you create a role, give specific permissions, and then that particular role can access the mailboxes on behalf of tens and thousands of users. Just to give you a little bit example how you can use those authorization, how you can request those authorizations through the SOAP headers. So this is like for direct logon. This is like, let's say if you are doing get folder API. This is how it looks like. For delegate access, what you would like to add is email address for someone else. On behalf of that user, you will be doing the operation. So add that particular header into the SOAP request. And for impersonation, you have to specify the primary SMTP address, right? And that's how you can do it for the impersonation. So it's pretty simple when you are basically asking for specific authorization, how you can do it is using SOAP. Just to give you perspective how it works. So let's say John wants to access his mailbox for some reason. The application server basically verifies the John's identity. So app server basically will authenticate John. Then the app server basically, it will have, the cache server will create a role for that app server, and give a specific permission to do impersonation. So the request then basically, and so application server is basically accessing mailbox on behalf of that user through impersonation. So as you see, that's how the impersonation is currently supported. And just to give you some more information on that impersonation today, we only support it for EWS access. Outlook and OVA and other clients, basically they just do support delegates. So impersonation is not supported there. So, but if you are using EWS, basically impersonation is your friend. Just some best practices, or just to give you some information on that. It's all or nothing. Impersonation is all or nothing access. You can't say that I want to access only specific folders or specific properties or attributes of the mailbox. So all or nothing kind of option. Delegate access in converse, basically you can define that allow only specific part of my mailbox or my folder to be accessed, and but again, it's a one-on-one relationship what you have to set up to do that. We recommend that use application impersonation when you are doing the accessing service accounts. And then the last part of it is like how you can set up this Exchange impersonation, right? So there is a Exchange PowerShell command what you can use. It is done through RBAC support. So you create a group first, and then you create an application impersonation role, and then you can specify the scope, like how many user accounts you want to impersonate. So this is kind of gives you some rough picture about.
Yeah, and it looks like the commandlet got cut off. I apologize for that, but I think will we be able to make the deck available?
Yeah.
Okay, so you will have the command in there.
Sure. Sorry about that. So this is about like the application impersonation and authorization models in EWS. With that, I think I've covered most of what I want to talk today. So I will hand it over to Venkat.
Thanks, Dheeraj.
Thank you.
So let's talk about auto-discover. So far, we talked about what EWS APIs looks like, how you can use the schema versions to your advantage, what the benefits of using the managed API is, and also application impersonation. One other thing I want to mention about application impersonation is some of our partners really like it because if they're accessing a large pool of users, it gets them out of the business of trying to store someplace a user's password, which people really don't like. So that's another benefit. And so this is about auto-discover. Really a powerful feature for EWS and Exchange in general. This is how when you get a new phone, you can type in your email address, authenticate, and then it discovers where your endpoint is. It's really the same service. And there are two things it's doing. One is it's really we have publicly published what the algorithm is, a way to try different combinations of URL constructed from the user's SMTP address to guess what the Exchange endpoint might be. And then in each case, use the credentials the user has provided, try and authenticate to the endpoint if that endpoint actually exists. And once that step succeeds, then you get back a configuration, you get back an XML file with the settings you asked for. And there are two different endpoints. In 2007, we rolled out a plain old XML one. This is what Outlook, for example, consumes. But starting from 2010, there's a SOAP endpoint published, and we highly recommend that you try to use the SOAP endpoint. The reason for this is the plain old XML one was largely tuned to what Outlook needed, which is a large set of properties, and it's all or nothing. You get everything back, and you have to go through it and pick the one EWS URL you're looking for. With auto-discover, you ask what properties you're interested in, it only returns you that set back. And our roadmap going forward, all the innovation, all the new feature support really will be focused on the SOAP XML. So if you want to utilize new features as new versions of Exchange roll out, really SOAP is the one you would go to. Benefit again of using a managed API is this auto discover algorithm can be fairly complicated to implement on your own, and the managed API bundles support for it. So it's a one-line call to try and to do auto discover. So that makes it very easy too. The advantage of this is in any large customer installation where they have multiple forests or in Office 365, wherever you don't have to worry about, you don't have to hardwire any configuration about where the user's mailbox is located. Is it on premise, in the cloud, which specific forest, which specific site? It'll help you deal with, constantly in the data center, we are balancing, we're moving mailboxes around either for availability reasons or for load balancing. And if your application is using auto discover, then it can stay current. That's a big advantage. And Outlook 2007 onwards, it uses it. Outlook for Mac uses it. Most of, I think, all the new ActiveSync clients beyond a certain version number also use auto discover. And so this is something, now we pretty much require applications to use auto discover, because going forward, our high availability story is tied to being able to move mailboxes around. And if you don't use auto discover, then your application is likely to break and cause customer pain. So where are the times when you use auto discover? You certainly use it in initial account provisioning, because you have to figure out where this person's, where the user's endpoint is located. And anytime you make a call, we may return some errors which indicate the mailbox has failed over, or there's a finite set of errors. Anytime you get that error, you should really do auto discover. Now auto discover, this call is a fairly expensive call. It could take up to 10 seconds to complete in the data center. So this is not something you do ahead of every EWS request. Our recommendation is that you make an auto discover call, cache the settings for 24 hours, and just re-auto discover every 24 hours to stay current. And if during the 24-hour period you get back an error, one of the errors, then we recommend you auto discover, because even if the EWS calls succeed, because let's say the user was in site A and moved to site B, and you continue to send calls to site A, in the data center we would proxy those calls to site B, but your application is going to start seeing increased latency. And so, there's still a quality of service issue there. And use the SOAP endpoint. In the data center, in Office 365, we have the SOAP endpoint available. Generally, Matt, maybe you can provide more details, but generally it should be available on customer premises too, right? So.
Yeah, it's. I mean, the assumption is that this is set up now. So yeah. we kind of assume that any enterprise customer has it set up. All the clients work off this too. So for ActiveSync, you're going to have this set up. Yep.
And I think there are some steps provided here which tell you how you can figure out if it is actually available. Some important things which are pointed out here. Don't assume that mailboxes in the same domain. It's really key for Office 365 that just because they're in the same domain that they would have the same EWS URL. They may not be. Especially with these tenants, we distribute those users over a large number of servers, could even be multiple sites if it's a large customer. So really, for the auto discover setting you retrieve should be for that user. And this is true even when you use application impersonation. So we've had to work with partners in the past where they complained of high latencies, and it's usually because they auto discover the EWS endpoint for the service account, and then they're making calls to access all these target mailboxes, which ends up in these requests getting proxied, probably even across data centers, which adds a huge latency. So what you should do, the recommended practice is authenticate as a service account for which you set up application impersonation, but this auto discover the target mailbox, store the settings for the target mailbox, and always go to that endpoint. That will give you the optimal performance. This is again, the auto discover algorithm we publish has the step where the first step is, I think you go look up the CP entry in Active Directory, which works in an on-premise case. If the application also is running where it can access the Active Directory domain controller. But in Office, if your app is purely in Office 365, or if it's targeted to purely Office 365, then that AD is not accessible to you. That lookup will fail anyway, and it's kind of an expensive call. So you can set a flag in the managed API to bypass the SCP lookup and just go straight to doing trying out the remaining steps in the algorithm. Now at this step, so like I said, throttling, I'm going to skip because I think Matt has a detailed dive in tomorrow. So really strongly encourage all of you to attend his talk, especially since he's been in the thick of some of the throttling issues we worked with in Office 365. I think the main takeaways from this is it's a platform agnostic API. This is this is where we're investing heavily from a roadmap point of view. We strongly, if possible, we want you to use the .NET client-side API because it'll make your life a lot simpler. And some of the how-to-dos here about the logs and customizing the user agent and logging the headers is really useful if you're working with Office 365 or even if you're working with a customer looking through the server logs. And Auto Discover is your best friend. Please use it, but cache the settings for 24 hours. That's the end of our talk, and I'd like to open up for Q&A.
So my first question is, you recommend something like caching for 24 hours, and is there any way from Auto-Discover to notify the client that he has to rediscover something, like Outlook has to rediscover some information because you moved the mailbox from server A to server B, and of course in a couple of seconds it's not going to work anymore, or it's just going to work due to proxying?
So the question is whether Auto-Discover has a way to notify that the settings which you had previously gotten are invalid and that you need to re-Auto-Discover. That's a great question. There is no notification mechanism in Auto-Discover, but the way this works is your application is making EWS requests, right? And so there's a specific set of error types we return, and for those error types, it means that, hey, you need to go Auto-Discover again. So as soon as your first EWS request fails with one of those set error types, it means that for that user you should Auto-Discover. So it's not a pure notification mechanism where you subscribe and listen, but it gives you the same functionality. Does that answer your question?
Yeah, this leads to another question. Are the list of code that makes the application aware that it needs to rediscover something documented somewhere?
Yeah. And if we can certainly follow up, and Dheeraj will send a list, but I believe either we have a blog article or it's on its way to being published right now with the finite list.
Okay.
But we can certainly send out the list.
Another point on that, there's kind of two scenarios. There's some scenarios where you'll actually get an error response back from an EWS request. In other scenarios, when we proxy the request from, say, one AD site to another to facilitate it, we don't want to break the client, right? So we proxy the request to get your response back. So from your perspective, you continue to get a successful response. It's just the latency is increased. And I don't know if this happens on premises, but in Office 365, we return a set of headers in that proxy scenario where it says it actually has the initial site and then it'll return the proxy site.
Yeah, we do. We can send, maybe we'll try to send out by email this follow-up.
Yes,
right?
sure.
We can send you. Yeah, there is a header we return when the request got proxied.
Yeah.
And so you could look for that header and say, okay, I'm getting proxied. Let me try to do Auto-Discover and see if I get a new URL.
And it's just for AWS, or is it also for RPC over HTTP?
No, it's only for this is all EWS.
Yeah.
Yeah, but Auto-Discover is also used by Outlook to do some HTTP over RPC. So I was wondering.
Sure, but the errors, the errors which trigger, Outlook to do re-Auto-Discover are quite different from the EWS set of errors. And so though that's a separate set of errors. If that's something you're interested in, we can follow up offline and get you the info. But the EWS error, like the name of the errors is a different set. Any other questions? Sure.
Besides the request ID header, are there any other major differences in functionality between EWS on Exchange Online versus on an in-house solution?
So
or behavior?
I
changes
think the
in-
question is, what are the major differences in behavior between the on-premises version and the Office 365? I think they generally fall into three buckets. One is diagnostics. We have added more diagnostics in 365, just because the developer, or the application developer, or the customer doesn't have access to the logs. And over time, a lot of them we found have value in the on-premises version too. But generally, there's a lag between when we can release it in the data center and when it ends up being available in a service pack or something of that nature. The second is authentication is a big difference. The authentication is in data center, we recommend really that you use HTTP or HTTPS, basic over HTTPS. And today, negotiate would work too. It's effectively using NTLM underneath the covers. But what we're finding from partner experience in Office 365 is there's a larger number of round trips. It's not optimal. Generally, I think the best performance partners have got is by using HTTPS, basic over HTTPS. Whereas in the on-premise world, but the default option is negotiate, and that works pretty well, whether it's using Kerberos or NTLM underneath the covers. The third is sometimes we will release functionality out in the data center because it's a much more agile platform, and in Office 365 we can roll out the updates. We may see how it does, and if there's demand in the on-premise market, we'll roll it out in the service pack. But Matt may be able to remember, but I can't think of a specific set of features off the top of my head. But that's always a possibility in the future. That's the way the services work.
Well, access to the Active Directory is restricted, correct? So, in the case of Exchange impersonation, where you typically are, discovering your user community, is there any kind of like a best practice that will be available to gain access to the user community?
So the question is, because AD is not accessible, how does the application build an exhaustive list of users it is supposed to operate based on? Did I get that question right? That's a great question. I have to think about it. I think a lot of this presentation assumes somehow that you know which user you're going to operate on behalf of. That is certainly true in a portal type application where that user logged in, the example which Dheeraj showed. But in a background sync job, I can see that being the case. I have to take that as a follow-up. Yeah, I don't have a good answer for that right now. I have to take that as a follow-up.
So you could do remote PowerShell to get mailbox, and then you can pull a list. But you're not going to do an LDAP query against Office 365.
that
you're going to
work.
have to do remote PowerShell.
Yeah. And anything else? Hopefully I didn't leave out anyone. Great. Well, thank you everyone for your time. Appreciate it.